Hello everyone. Good afternoon. I could see good number of people in the audience who have already joined and could see the number is still increasing. Okay, so I'm Kinjal Haryani from Automotive Marketing team of Tata Elxsi. I hereby welcome you all in this webinar on intelligent battery management system. As you all might already be aware, Tata Elxsi is a global design and technology services company that empowers businesses to thrive in the digital era. With expertise in areas such as automotive, broadcast, communications, healthcare, and more, we help our customers accelerate their innovation, transform their customer experiences, and stay ahead of the competition. Tata Elxsi is a preferred partner to global OEMs and Tier 1s suppliers, offering differentiated solutions and services mainly focusing on connected, autonomous, shared, and electric. Our service offerings in electrification area include vehicle system engineering, mechanical design, embedded engineering, simulation and analysis, cloud engineering, verification and validation, tech support and program management, wave and compliance testing, benchmark and teardown, functional safety and cybersecurity, as required for electric vehicle in-vehicle system and its ecosystem that includes power converter, energy storage, connectivity, vehicle design, energy infra ecosystem, and EV digital ecosystem. We also have solution accelerators, which can be internal assets and reference designs to jumpstart your electrification journey, such as under EV subsystems, we have power converter combo unit reference design, BMS hardware and software, scalable PM synchronous motor, synchronous reluctance motor and controller. Then we have software and frameworks designs for TE AutoSAR stack, EVSE EVCC 15118 stack framework. Then we have plant controller models of OBC, DC to DC, motor, inverter, and BMS. Then we have e-mobility hills, that is hills hardware in loop system validation as a service. Then we have cloud and digital platforms, that is digital twin for battery, Tether, that is IoT software platform, TEDx, that is data analytics platform. Then we have prognostic and predictive analytics platform. Key benefits of partnering with Tata Elxsi is accelerated time to market, scalable future-proof solutions with optimal efficiency and enhanced user experience. Now, coming to our today's webinar topic, that is intelligent battery management system. The current demand boom of electric vehicles has forced OEMs to get their products faster to market. Lithium-ion cells require a sophisticated monitoring and controlling mechanism, as they are prone to damage if discharged before a certain threshold or if overcharged. These cells also have strict temperature limits for which a battery management system is needed to maintain a safe operation area for the safety of a battery pack and for optimizing battery performance. Tata Elxsi and Renesas experts will examine and discuss on challenges in the current EV market, driving factors and solutions offered by an intelligent battery management system. Addressing to this, in the speaker panel, we have Mr. Arun P., Senior Lead Engineer from Tata Elxsi. Arun has got more than 12 plus years of experience in the electronic system design and development. Currently, he is working as Senior Lead Engineer in Energy Storage System and Battery Management Systems for electric vehicles and hybrid electric vehicles. Arun holds a master's degree from Calicut-based National Institute of Electronics and IT in the field of electronics design technology and bachelor's degree in electronics and communication engineering from Calicut University, Kerala. He is currently working out of Tata Elxsi and Trivandrum office. And we have Dr. Bhakti Joshi, staff engineer from Renesas Electronics. Dr. Bhakti has worked in the semiconductor industry for about 4 years. She has worked in the fields of motor control and battery management system. Prior to this, she has worked as an assistant professor in IIT Mandi for 5 years. Dr. Bhakti holds a master's and PhD degrees from IIT Bombay in the field of power electronics and motor drives. She is currently working out of Renesas Pune office. It's pleasure to have you both on board. Also, I will request audience to feel free to write down their questions if they have any time during the session in the chat box available. Now, I would like to pass on the mic to Arun and begin the session.
Thanks, Kinjal, for the brief introduction. Hello, everyone. Welcome once again to the webinar on Intelligent Battery Management System. Before we jump into the BMS, let us discuss a few concerns in EV segment in India. So Indian EV market has been growing steadily over the past few years with the increasing awareness about the environmental concerns, drive towards the energy independence, cost savings on the ownership of the vehicle, and government policies, subsidies, etc. So sensing this demand boom, startups and OEMs introduced new EV products to the Indian market. But there are a couple of EV fire accidents reported in last year, so which we have seen through medias and newspapers, etc. So this that resulted a loss of lives and damaged properties as well, that everyone is aware. So by analyzing this scenario, experts say the main reason for these hazards are due to the poor quality of the cells and electronic things used to part of the battery, non-compliance to the safety standards, lack of well-built, reliable BMS, and a solution not considering the extreme weather conditions in India, then maybe inadequate testing and validation of the battery system as well. Solutions to these issues would be a well-built battery system with a well and reliable BMS. So these solutions should target on the performance, protection, and connectivity of the battery pack, and hence it has to give the safety as much to the user. So considering this fact, Tata Elxsi and Renesas has joined hands together to address the key requirements in the BMS for EV segment, especially two-wheeler and light EV segments. So under this collaboration, we have opened a platform called the Next Generation EV Innovation Center to develop the target solution for electric vehicles. So Renesas, pioneers in the semiconductor devices, will offer their hardware products, drivers, and expertise from their side. Tata Elxsi will leverage its experience in the hardware, software, and system integration side to create the reference solutions. NEVIC products and service offerings will accelerate e-mobility adoption and assist customers in overcoming the time to the market and the technology complexity without compromising on the safety, reliability, and the time that may take for this validation and testing. So with this, the center will develop reference designs and accelerators for critical electrical vehicle subsystem, such as the battery management system, motor control unit, connected clusters, and gateway controllers, as you can see in the image. So, and these will be incorporating the reusable hardware and the software application modules. So I would say NEVIC will be a one-stop solution for embedded hardware, software, then mechanical testing, validation, and even for digital platform for this EV segment. So with this background discussion, I would like to take you to the main topic of our discussion, which is intelligent battery management system. So in this session, we will see in detail what is the role of a BMS, what are the features part of a BMS, and the consideration we may need to take or consider for designing an intelligent BMS. So the first part of this webinar will be discussing on the features and consideration for intelligent BMS, mostly on the system side. And second part would be discussing on the hardware platform and solution Nevic is offering and how that would be aligned to these requirements. So let's start. So first, we will discuss the basic functions of BMS. As we are aware, the lithium-ion battery itself is very unstable in nature, so that is a safety threat to the user. So BMS primarily oversees the operation of the traction battery system and protect it from overcharging, over discharging, and in case of overcurrent and during the charging and discharging also. And thermal management and monitoring is another key aspect of BMS. So BMS plays a critical role in monitoring, protection, and ensure the safe operating area of this battery pack. From these monitored parameters, voltage, so that can be a cell level voltage or a pack level voltage, temperature, and the current, BMS could estimate the SOC, state of charge, SOH, state of health of the battery pack, and enable the protection and execute the fault management. So BMS could estimate all these parameters, and BMS will also optimize the available energy, perform cell balancing, and it may extend, or it's supposed to extend the service life of the battery pack. Now let's look at what are the key factors driving the evolution of BMS as an intelligent BMS in the EV, or rather EV ecosystem as such. So the lithium-ion batteries need the support for BMS for various reasons that we have seen already, that for sure. Firstly, the lithium-ion, especially the NMC chemistry, is unstable in nature and is prone to thermal runaway and explosion. So a constantly monitoring system to make sure the safety of the battery is very essential. So temperature monitoring, identification of hotspots in the battery pack, and thus preventing the thermal runaway is a part of thermal management, and that is a key aspect which we already discussed. The lithium cell have a non-linear charging characteristics. Discharging are the same thing. There is a non-linear charging and discharging characteristics. Hence, we need an electronic system to enable or handle these non-linearity so that the state of charge and state of health and many more state estimates are accurate, which is extremely important for the overall operation of the EV as well as the user experience point of view. So another key aspect is the battery is made up of number of cells, modules than the pack. And there can be difference in the charge levels among these modules or cells. So this can be an issue because of the underutilization of the battery pack can happen. Overcharging of a particular cell can happen. And that may cause an unsafe operating condition also. So cell balancing and the capacity estimation or the optimization is a key requirement that drives the BMS evolution. As battery is the costliest element in the EV, as you are aware, extending the usage life of the battery is a key to sustaining the ecosystem or e-mobility ecosystem as such. So as the battery life is affected by the usage pattern, BMS needs to protect the battery from the abuse by maintaining the battery within the operating limits or safe operating limits. So overall, an accurate BMS that performs the above mentioned functions will help in optimizing the vehicle design, performance of the vehicle, and cost of the vehicle as well. We'll now look at some leading trends in BMS. The major advancement and improvements are suggested in 4 major areas as shown in the slide. Make the BMS more intelligent and reliable. So on the measurement slide, the simultaneous sampling of all input channels with a good accuracy of AFE is very important because this accuracy has a direct relationship with the estimation accuracy as well as the algorithms resides in the BMS itself for the control purpose. Current and temperature measurement also can be synced with the voltage measurements to improve the data correlation, and hence it will improve the estimation accuracy as well. So minimum conversion time is another important parameter to look into while designing the fast response BMS to keep an eye on the fault reaction time to the minimum level, etc. So the BMS software is also growing in complexity, propelled by the recent advancements like in the computing platforms, connectivity, simulation-driven approach, etc. Rather than using the empirical or electrical equivalent models, the multi-physics and AI-enabled battery models which run on high-performance platform, such as cloud or something, can sync with the real world data, and that can be self-optimized and update. Optimum cell balancing, fault management, and isolation, then secure communication, etc., has to be met to meet the safety requirements of the whole system as such. So BMS can be programmed and configured to adapt. There are various chemistries of batteries available. So various chemistries of batteries, different sizes, different voltages, different power levels, and various system requirements and applications as well. So the flexibility in use in wide range of application and allows for efficient integration with different types of batteries and the different power system. So apart from the temperature sensors, when we are talking about the protection side, the gas sensors, which can detect the early thermal runaway condition, or the humidity sensors, which can detect the moisture inside the battery pack, would be a added advantage to prevent the fire accidents. The cloud connected BMS can achieve features like the prognostic, remaining useful life, and early safety warnings by combining precise algorithms in the cloud space. So let us discuss these aspects in detail in coming slides. So first we will discuss a few hardware consideration for the BMS AFE. The slide shows the AFE selection and safety targets for BMS in requirements. Isolated communication and then the secure communication should be an essential factor for that. ISO 2626 SLD compliant AFE is preferred to meet the functional safety requirements nowadays. Then it should have adequate number of channels for the voltage and temperature measurements, and with a good accuracy and resolution. Then the wireless BMS architecture can also be considered to ensure the isolation and helps reduce the wiring cost and complexity. So also BMS should support multiple communication interfaces like the CAN or the CAN-FT interfaces for the system interfaces like a VCU or NCU in the system. And it may be useful for the diagnostic purpose as well. And these IFEs or the microcontroller assets should support the power saving mode like a vehicle or sleep, which will help to improve or extend the battery SOC. So more details about these AFE and its features will be explained in the next part of the webinar by my colleague Bhakti, and we'll move on to the next slide. So we will discuss quickly on the estimation part as well. So as I mentioned, there are SOC estimation, SOH estimation is very much required for the BMS perspective. We will see more estimates, which is essential to make the BMS more reliable. So these algorithms are vital part of BMS, where the different state of battery pack in terms of the charge or health or the energy level also, which can be accurately estimated and used for the performance optimization and give the information to the user as well. So collectively, this SOX estimation is a crucial evaluation indicator to assess the performance of the automotive BMS. So this can be a very critical factor by designing while designing the BMS as such. So there can be inaccuracies in the estimations, and there are majorly due to non-linear dynamic behavior of the cell that everyone is aware it is not linear. So lack of precise cell equivalent and the cell characteristics data is another important factor. So there is a characteristics test need to be done, and we have to extract the characteristics data out of the data which is not available part of the data sheet, and we need to feed that to the algorithm to make the algorithm more precise. So aging of the battery with the changes in the internal parameters, example internal resistance, and that also need to be considered. So the major estimates as of now in most of the system has considered are like a state of charge, which is SOC, state of health SOH, state of power SOE, then state of energy SOP. Additionally, two more estimates like state of function SOF is kind of an added figure of value that delivers details about the ability of the battery to function or deliver that function at that particular point of time. The safety is another representation which give the degradation scale of the battery pack due to the previous abuse scenarios, if any happened already. So these two additional parameters will help you in giving some info regarding the safety side of the battery pack while using. So there are multiple methodologies for the accurate estimation of these battery states, which I have represented in the slide itself. So like the conventional method is there, laning method is there, adaptive method is there. So out of these, the Kalman filter-based approaches are very popular because of its fairly accurate and moderate in the calculation intensity. Now, we will move to the next part. So we'll see the balancing, which is a key aspect in the battery protection and optimization, which we discussed already. So cell balancing is a state in which all the individual cells have a same voltage, and any deviation with respect to this voltage will maybe above a particular threshold considered as an imbalance. So what is the reasons or what are the issues part of the cell imbalance? Accelerated cell degradation is one of the issue. Then incomplete charging of the battery pack can happen. Incomplete discharging of the pack can happen. Then thermal runaway due to the overcharging or overheating of a particular cell which is imbalanced can also happen. So it is a safety threat actually. So BMS balances cells to ensure the same voltage and that is maintained across all the cells when we are considering different series combination of the cells which then make module then to the pack. There shall be multiple modes for this balancing also. For example, there can be a manual or auto mode. So if I take auto mode as an example, auto balance mode for balancing during system the sleep time or ideal time. So there will be some power savings part of it because the main microcontroller, the BMS master or something, is no need to wake up and do and coordinate the other balancing itself. So maybe more details on the balancing mode will be discussed in the next part by Bhakti. So the balancing approach for cell balancing consider various factors, not only the voltage part. It has to consider the SOC, it has to consider the system modes, it has to consider the thermal data, that is the temperature of the board, because when you are doing the cell balancing, there is a chance to increase board temperature or maybe localized heating. So nowadays, the balancing current of around 250 to 300 milliamps is considered or designed to have a quick balance. Certainly with the support of external MOSFET, because the internal MOSFET cannot support that much high current, and it may raise the chip temperature or the die temperature as well. So as you are aware, passive cell balancing approach is very common because it's very less complex and low cost implementation is possible with that. So we will see the next aspect, which is on the connectivity side. So with the connectivity, BMS software and firmware updates can be delivered over the air to the battery system. Oh, it not only applicable to battery system, almost all the components have those features now. So manufacturers can easily deploy the bug fixes, any feature upgradation or new feature addition itself, and that can lead to the performance enhancement. And all these are not required with the physical access itself. That is the important point. So the FOTA, the firmware or the update application, allows BMS firmware to be up to date with the system. The FOTA application allows BMS firmware to update in the background as well. Since the BMS is a critical unit, zero downtime is an important aspect for FOTA because unavailability of BMS for certain duration when it is getting updated, it's not a recommended one. This system has been incorporated with a rollback mechanism that is triggering the event of failures, if any, happening in between the update. So for instance, I would say if there was a disruption in the system during the update, the system rolled back to the previous default image and reinitiate the new update later, maybe whenever the safe time is arrived again. As connectivity increases, it is crucial to ensure data security and privacy. Yes, I'm talking about the cybersecurity part. So BMS connectivity should improve in terms of robust encryption protocols and that ensure the secure data transmission to protect the sensitive information part of the BMS. Proper access control mechanism and authentication mechanism should be implemented to prevent this access or unauthorized access to the BMS. So cybersecurity would be an important requirement, and that must consider the user-defined services like security services, secure boot, then autonomous memory checking during the runtime, then a quick encryption, decryption for signature validation, and these possibilities or capabilities contribute to optimized battery performance, efficient energy management, and improve overall system reliability as such. So next part of the connectivity, we will be discussing on the cloud and detail part or retail twin part. So with the recent developments in cloud computing, big data analytics, and machine learning, so the system has we can deliver invaluable insight which drives adaptive control of BMS with improved performance. Predictive maintenance and machine learning algorithms can be used to predict the health and performance degradation well in advance. So by analyzing historical data and patterns, it can be improved or it can provide insights on the remaining useful life, that is RU, which we discussed already, and recommend maintenance, action, or replacement before the fault is actually occurring in the physical system. So this helps in optimizing the maintenance schedule, the maintenance downtime, or the minimum downtime for the maintenance, and reduce overall maintenance cost as well. So next part would be DT, which I explained already. So the framework of DT has got two parts, one on the onboard BMS part and its offboard counterpart. Onboard system consists of a battery pack and a BMS and associated physical sensors part of the battery system itself. The offboard system is a cloud platform where digital twin of the battery, the cloud functions. Then other value-added services also can be hosted or might have hosted already. So once the DT is deployed, it will get refined based on the real data from the battery, the actual system, the physical system, and accuracy will improve over the time. So in short, the BMS can collect and logs the valuable data like the battery for the performance, including the voltage, then current, temperature, and the historical usage patterns. So this data can be analyzed on board or off board to gain insight into battery behavior, then identify trends, optimize feature like our future battery designs, and or the usage strategies also. So on the next slide, I would like to summarize on all these aspects what we discussed as of now. So to make the battery pack more safe, reliable, and robust, I think we have to focus on three main areas. One on the pack design, then on the BMS design, then on the connectivity side. The emerging trends which we are discussing in the BMS reflects the industry's focus on advancing battery performance, optimizing energy management, improving safety. Then that will be supporting for the evolving needs of electrified transportation itself. So these features make it essential for the effective management and utilization of batteries in various applications. Yeah, so with this, I'm concluding the first part, and on the next session, we will see more on the BMS hardware platform and features, what we are offering part of NIBIC. Thanks, everyone. Over to you, Bhakti. Thank you.
Thanks, Arun. Hello, everyone. I'm Dr. Bhakti Joshi from Renesas Electronics India. In the earlier part of this webinar, we looked at the overview of battery management systems and discussed the system level operation of the same. we took an overview of various functions such as battery pack monitoring, battery state estimation, optimization, and most importantly, protection. We also saw that to practically realize these functions in an effective manner, there are certain performance related requirements from the hardware devices that are used in the BMS, such as the analog front end ICs and the microcontrollers. In the second part of this webinar, I shall now take you through the details of Renesas BMS hardware solutions with an emphasis on the device level features. Here, we can see an overview of solutions offered by Renesas in an electric vehicle architecture. While this slide shows the Renesas devices for motor control, onboard charger, and DC to DC power section, let us focus our attention on the devices related to BMS, which are shown on the right hand side of this slide. For battery pack and cell voltage monitoring and temperature measurement, analog front end ICs, which are also known as Battery Manager IC or BMIC, such as ISL 78714, are used. These BMICs often support two wire daisy chain communication, and multiple BMICs can be interfaced together for BMS scalability requirements. RAA 270005 is a power management IC or PMIC for RH850 series microcontrollers. RAJ 28000X is a family of intelligent power devices or IPDs, which are N-channel high-side switches and can be used in load-side pre-charge circuit as well as for connection and disconnection of external loads. RV1S2752Q is a photocoupler for isolation. Let us now take a look at the historical perspective of Renesas BMS devices. This slide gives an overview of history of Renesas BMS solutions. First and second generation industrial BMS devices, which are ISL 94208 and ISL 94203, were released in the years 2006 and 2009 respectively. First automotive grade ASIL B and C compliant device, ISL 78600, was released in the year 2013. This was also the first device to include distributed daisy chain communication in the vehicle. ISL 78714 is an ASIL D compliant device that can support up to 14 channels. The next generation BMIC device family can support up to 16 channels and will be ASIL D compliant. In this slide, we will take a look at the device capabilities of Renesas BMIC ISL 78714. We can see the functional block diagram of this IC here. As mentioned in the previous slide, ISL 78714 can support up to 14 channels. This is an AEC Q100 qualified device that can support ASIL D systems. Cell voltage measurement accuracy is plus and minus 2 millivolt. This device has a robust, isolated two-wire daisy chain communication capability, and up to 30 such devices can be connected over daisy chain. Daisy chain communication can be capacitive or transformer coupled for larger distances. This BMIC supports internal and up to 6 external temperature monitoring inputs. Internal and external cell balancing capability is also supported with different cell balancing modes available. This slide gives the details of Renesas BMS reference design that includes BMIC ISL 78714 and RH850 P1M microcontroller. It includes a high voltage side comprising 5 ISL 78714 BMICs that are interfaced with each other via onboard capacitive daisy chain connection. Up to 70 battery cells can be monitored simultaneously with this solution. The RH850 microcontroller communicates with the ISL 78714 BMIC to monitor cell voltages, pack temperature, and current. It records significant fault detection and also controls cell balancing. The RH850 microcontroller can interface to multiple CAN, LIN, UART, and RS485 buses and controls multiple PWM outputs. This BMS system offers the best accuracy and long-term drift. This solution is a complete evaluation platform supporting setup and data logging via CAN and UART communication protocols. A graphical user interface is provided to display measured data. Layout files and low-level drivers are provided along with hardware, software, and interface reference manuals. A complete BMS solution with next generation BMIC, which supports up to 16 channels, and RH850 U2A microcontroller is currently under development. Here we see a brief introduction to the next generation BMS proposal, which comprises pin compatible and ASIL-D compliant BMS devices. As shown in this typical connection block diagram, up to 30 new BMIC devices can be connected via daisy chain communication. This device will have true simultaneous sampling and will support internal as well as external cell balancing modes. New BSIC is a battery system IC with shunt type current sales capability. This winning combination solution from Renesas will also include contactor driver and communication ICs. In this slide, a wireless BMS solution is illustrated using BLE module DA1453X. Next generation BMIC devices are connected via daisy chain and the master SPI device is connected to BLE module DA1453X. Multiple such devices can talk to each other over wireless communication. This system allows more flexibility regarding the physical placement of batteries and BMS subsystems as compared to the wired solution. DA1453X is an ultra low power BLE 5.1 system on chip SoC device for wireless BMS and is ideal for battery life cycle standardization based on the open Bluetooth LE standard instead of a proprietary wireless protocol which is unique to a single supplier. As mentioned in the previous slide, Renesas's automotive wireless battery management system eliminates wire harnesses, allowing for flexible battery placement, simplifying the development of scalable electric vehicles. This makes the system cost effective while also achieving isolation between the low voltage and the high voltage sides. Using optimized BLE architecture, cell data collection throughput can be maintained. Simultaneous sampling of all cell voltages can be achieved by maintaining timing synchronization using optimized BLE stack. In conclusion of the second part of this webinar, I will now summarize the important points. We saw that to satisfy the stringent system level requirements of accuracy, speed, reliability, and safety, discussed in the first part of the webinar, Renesas BMS devices offer accurate and reliable solutions which are ASIL-D compliant. Next generation Renesas BMS devices are pin compatible and offer a compact and low cost solution. These devices are suitable for all lithium ion battery chemistries, including lithium iron phosphate, that is LFP. We also saw that wireless BMS solution offers additional benefits such as wireless connectivity over BLE and flexibility with respect to physical placement of the batteries in addition to reduction in cost as compared to the wired alternative. Renesas's complementary product portfolios of analog, power, embedded processing, and connectivity work together to deliver comprehensive solutions. Our product experts have developed winning combinations that help our customers accelerate their designs and get to the market faster. This is the end of my presentation. I will now hand over to Kinjal to take questions from the audience. Thank you.